very warm welcome to the German watchmaking channel. Today I got something special for you, and it also traveled quite far. Comes from Brazil with DHL Express, but the packaging was actually smelling like a car workshop, like benzene or oil, maybe both. Maybe they transported it in the airplane tank. I don't know, but let's have a look. And it's a rare one. It's an Omega Seamaster f300 tuning fork watch as a diver, and there are not that many of these around anymore. As you can probably imagine, I bought this one as a non-runner, as a defective watch, and in this video I'd like to show you how to diagnose, fix, service and fine-tune these kind of watches, and on top give this particular specimen a nice case rework to make it look great again. So let's see what we have here. After unscrewing the screw down crown, I'm trying to set the time here, and that's already really bad news. The second hand is not supposed to move when the time is set. That can mean a variety of things that is wrong with this watch, but I'll get to that later. The case overall is pretty scratched. There are two screws only on one side of the case that holds the bracelet, it seems like. Here I'm loosening the clasp. And this watch is from the 70s and looks to have been worn a lot. Very scratched up case back. Let's try to open it. And it's not tight at all. Just coming right off. Well, at least easier for me. But also means that someone was in there and might have done some damage. So we don't have a battery that I immediately can see. And there seems to be corrosion from the leakage of the previous battery. And obviously the case clamps are missing. And there's screws. Well, this corrosion doesn't look too good, honestly. Pretty sure this is the reason why it failed at some point. And then a lot of the electronics could have gone bad during this leaking accident. But I am gonna try to save as much as I possibly can from this movement, which is basically an ETA or ESA 9162 that Omega took and made its caliber 1250. And what I'm gonna do first is I'm gonna free up the electronics module, which is sitting on top of the rest of the movement, and I'm gonna do some basic diagnostics to see what is wrong with it, what might still be usable, and that is going to give us the plan how we can proceed in this operation. So here I'm slowly lifting up the electronics module, and underneath we can see the timing module. That's how Omega describes it, which doesn't look to be in too bad of a condition. And here we can see the electronics module again, which is a tuning fork driven by two coils, where one of the forks has a tiny prawn with a jewel that drives an index wheel, which you will see in a bit. But first, let's do the diagnostics of the RC unit on the right and the T unit on the left. And in the service manual of Omega is described which kind of resistances have to be between which measurement points. So between 0.4 and 5 we should have around 5 to 10 kilo ohm, which we fail to have. Secondly, the same between 4 and 3, which we get with 6 kilo ohm, which might be the first good sign for our T unit. Then we should have between 1 and 2 kilo ohm here. Let me find a point, and yeah, 1.7 seems to be okay. Now I'm removing the insulator, and here I would obviously like to see infinite resistance, which we have. That is good. Now between 2 and 3 and 2 and 6 we would like to get 2 to 10 kilo ohm, which we fail to get. And changing the polarity, we should have open line, which we do, but not easy to trust this module anymore. Also having the amount of battery leakage, I'm gonna exchange both units, which I could do thanks to a donor movement that I got, a new old stock ETA 9164, which is the day date version. but the electronics module is identical. Thus I'm able to take parts like the electronic units and other things like this little part, for example, here. If you have a look, this is the adjuster plate for the retain click, but I'll get to that later again once we're in the reassembly process. But now we're getting to a very delicate part. Once removing the index wheel bridge, we free up the intermediate wheel and the index wheel. Here, under very heavy magnification, you can see the 300 infamous little teeth, where the prawn jewel is grabbing into and pushing the wheel forward, thus making the watch run. But here you can see my smallest screwdriver tip in comparison, and I think it gets obvious why these are so easy to destroy. But let's continue the disassembly process. Here I'm taking off the resonator, so the tuning fork, if you may, and this little prawn arm that you can see here is what is driving the index wheel. But that's it when it comes to components that can be disassembled from the electronic module. Now we turn our eyes to the timing module. Firstly, releasing the stem and flipping the movement as usual to get it safely out of the case. And I have to say I really like this dial. The red accents, 1970s Omega hands. Looks like the clutch wheel already fell out, not supported by the stem anymore. But before doing anything else, I'd like to bring this dial into safety. So taking off the hands, storing them for later. Obviously they will get new loom. This one looks rotten and green. Now, easy enough for this kind of movement. There are no dial screws, but these arms, as in many ETA movements. Just pushing them outwards, opening them up, and then the dial is free. And we can see some kind of service mark or something else. Let me know if you have an idea. But now I can continue to disassemble the timing module. Firstly, this date guard disc here can come off. It has its spring already integrated, which is pretty convenient. Then the minute wheel, the intermediate date wheel, the center wheel with cannon pinion, and luckily enough, the date disc is not broken. Typical failure point of these movements, and also quite expensive to replace. And then the date indicator driving wheel. Now for the keyless system, the setting lever spring, springing away, and that's the yoke, and the yoke spring behind it, and finally the setting lever. Back around to the other side, so removing the battery clamp and giving this friction spring half a turn, so I can remove the wheel train bridge that houses the second pinion or second wheel and a friction wheel. Also a very interesting part. Good point of failure, as you will see. There's also plastic involved here. That's where the friction spring grabs into. And that's the friction wheel. Wants to be lubricated very specially. And here this little isolation plastic part to protect the battery. Having another look at this corrosion. I think I can't do much about it. I'll just give this timing module a brief clean before, removing some corrosion, and then with isopropanol getting it clean. The jewels look alright, although dirty, but nothing that the watch cleaning machine will not happily like to fix. Turning my attention to the hands, I wanted to remove the old loom, but since I was not entirely sure what material they used back then, I read different things in the internet. I did it in a plastic bag, but once they're free, they are ready to receive some new 100% safe luminescent material, so they look fresh again. Firstly, the minute hand and the hour hand following. So that is the time where I finally put my attention to the case. Those 4 screws that go kind of diagonally into the case hold the inner part where the movement goes into, and both actually don't look too great. A lot of rust, surface rust, but nonetheless. The glass is actually not too bad. Tiny scratches, but mainly just dirty. Here we also have a lot of rust. And now I'm trying to remove the bracelet, but that didn't prove to be easy. It turned a tiny bit, but then got completely stuck. So I put it in WD-40 overnight. Wanted to soak it and maybe remove some rust and give it some general lubrication. But I broke off my screwdriver tip, and also onto the next screwdriver. All I could get is a half turn. So back into the WD-40 it is. Another night might solve the problem. And actually putting it into a clamp and just rotating little tiny steps, turning it by hand. At some point I could get it free, and I was really relieved because I did not want to polish this case with a bracelet attached, especially with what I had in mind. So now let's see how the pin looks like. Definitely a bit bent and rusty, but nothing much I can do about it. Hard to get by new ones at this point. But onto the reassembly. And this is the friction wheel that I was promising you. Here from the Omega service manual, the 2 points where you need to lubricate. And if you don't do it correctly, the power from setting the hands can directly be transferred to this index wheel that I showed you earlier. And those 300 little teeth can be shaved off quite easily. And then, for example, the second hand moves when you set the time, as it was present in my watch. But now, hopefully correctly lubricated, friction wheel can go back onto the timing module. Seconds wheel as well. Seeing that everything is the correct place. And then tightening it back down. Checking if everything moves, and then giving it a little bit high viscosity lubrication. Putting the stem back into the movement. And adding some grease where metal hits metal. Here the setting lever. Back into place. Very carefully. Here this very special yoke. Getting a bit of oil. This is also the place it should be oiled from the service manual. Omega is very specific about that. Yoke spring. Bringing tension. And the setting lever spring. As almost always, firstly tightening it lightly. Not fully screwing it down. Then it can be clicked into place before properly screwing it down. The rest of the wheels on the dial side coming back into place. Here I'm adding some HP 1300 medium viscosity oil. And this part is actually not too difficult, pretty straightforward. Also the date mechanism is pretty easy to handle. Also, as I mentioned earlier, thanks to this integrated spring to the date indicator guard. Here, easy enough, tensioning the spring, screwing it down, and then we can test if the date flips. And it absolutely does. Also going to time setting mode. Everything seems to spin. Here's still some lubrication at the date disc, and the friction spring can come back to the seconds pinion. Here I'm already back at the electronics module, lubricating the 2 jewels for intermediate wheel and index wheel. Here you see me putting the new resonator in place. Screwing it down with 2 screws. Firstly the outer one, and then the inner one. Also making sure those are tight, because the position is really important. And here the point of truth, lowering the new index wheel into place. Intermediate wheel on top. And their little bridge. Need to be very careful here, because you don't want to bend anything. So I'm loosening the screw also very lightly. Second one also trying to be very straight. Since I don't have the proper movement holder, I'm doing this on my cushion. Also not easy at all to bring this screw back into place for the adjuster plate. But as with many things in life, once the start is made, it gets easier and easier. Now this adjuster plate with the prawn jewel pushed back into place. Need to be very careful here not to push it against the index wheel yet, as this is going to happen by fixing this screw later, which I'm firstly going to do loosely here. And then under the microscope I can push it closer to the index wheel. Here, closer and closer until it almost touches. But firstly I'm gonna install the new T unit. And also here you have to be extra careful not to damage the coil. The windings are ultra thin, and if you break one or slip with your screwdriver or tweezer, you might just break the connection and the coil is gone. Here the RC unit pushed back in place. Also fixing the screw here. You need to push it a bit in order for the screw to reach the house. Then the insulator can come into place and be screwed down. And then all we can do is hope that it works. I also took this little isolator plastic sheet from the donor movement because it looked a bit better, obviously. Putting this back in place, and then I can drop the freshly serviced and repaired electronics module onto the movement, tightening it with its 4 screws. And I did that a lot, so I'm gonna show it here, but not every single time. I hope you can forgive me, because I have to say I took it off and put it back on more often than I would like to admit. But here I'm already installing the battery. and making sure the retain click is in the perfect position. And then pushing the stem in, seeing if it wants to run, and there it goes. And honestly, that was such a relief at this point. I was not sure if it's gonna go because of the mix between all the new parts, but the movement actually runs. Although in the beginning it was running double as fast as it's supposed to run, so it made 2 minutes in one, which is caused by the so-called double indexing, where 2 teeth are pushed in one movement. I could resolve this issue by adjusting the retain click, the prawn on the right side, making it a bit tighter so no teeth are skipped. But at this point I was just happy that the movement is running. The electronics module should always be removed in date setting mode, and I am removing it because I want to put the dial and hands back on, and this should never be done with the electronics module present, because also here obviously the very fragile index wheel can be damaged. Fixing the dial is easy though. Now seeing when the date switches, and there it goes. So I can set the time on 12 o'clock exactly. Firstly the hour hand, and then the minute hand, making sure it's perfectly aligned. Always checking for space in between so they can run freely. Seeing if everything runs smoothly before placing the seconds hand. Here, very carefully pushing it down, and obviously without the electronics module, now the seconds hand will spin freely. And what I did now is probably not necessary, but I wanted to know that the movement is running good before I would put it back into the case. So I decided to place the electronic module one more time, now with the dial attached. And I wanted to see that the seconds hand is not moving anymore, which it isn't. Now fixing the battery, and the watch runs. And to make sure it runs good, I wanted to time it, and I did that with a phone stop timer. But just in case I pressed a little bit too early or too late, I also used a timer here in my cutting program, letting it run parallelly. And that was my final result that I settled with. Obviously I had, as I told before, some turns where it was running with double speed, some where it was stuttering, always tiny adjustments to the screw for the retain click. But with that done, I turned my attention to the case. Firstly, the case back here, this old gasket, as brittle as the bakelite bezel of this watch. And for the finish I wanted to achieve here, I activated my mini lathe. Slowly filing out the scratches and give it a nice brushed finish in the end. Obviously protecting the middle and getting this nice circular brushed finish. For the casing itself, firstly I'm using a Manhattan wheel to even out the deep scratches and to get the surface clean again. Also for the angles, I don't want to polish it too flat. Same goes for bracelet and clasp. First the deep scratches with the Manhattan wheel, which is some rubber compound. Very good at evening out deep scratches without taking off too much material. And after mirror polishing it, I taped off the edge and brushed the side, as my plan was to leave only the angle mirror polished and everything else brushed. Which you can see here, the side is brushed, the rest taped off, And now we switch it around. The side and the edge is taped off in order to brush the top. Need to be careful to do it straight in order not to get any side brushing. And that's the final result. Mirrored edge and brushed top, but you will see it maybe a little bit better later. For the bracelet, also mirror polish. Here this is my cutting wheel with a lot of polishing compound on it for stainless steel. For the clasp, before mirror polishing, I'm taping off the omega sign because this little square should not be mirror polished. Leaving it like that. Now I can mirror polish it. Here already onto the next wheel, giving a bit more shine. Taking off the little tape. Now a mirror polished clasp. And then brushing it. Which then looks like that. And I'm very pleased with the result. For the bracelet goes the same. Very linear movement. And here you can see the results so far. And for this inner tube, I decided not to take it apart because I was too afraid to destroy the gasket and not get another one. So I'm using my Dremel tool to get rid of the rust, which you can see flying here in form of dust. And then finally still polishing the glass. It's a mineral crystal. And I'm using 2 compounds and a Dremel with a light polishing bit to just even it out a bit more and give it a bit more shine. Obviously protecting the bakelite bezel, since that is the most valuable part about this watch. And the result is actually pretty nice. Got a bit more shine and these micro scratches are gone. And after clean in the ultrasonic, it really looks nice. Like a new watch. Obviously the bakelite bezel did not go into the ultrasonic cleaner. And here you see me again disassembling the electronics module. Taking the stem out because now it's time, after a good blow of air, to put the movement back in the case. Of course, always the clutch wheel falling out. Here it comes back, and I'm still putting some silicone grease to the stem and the crown. Putting that back into place. There it clicks in. You see the date swaps. We're in date setting mode, remember? And those are actually some generic case clamps out of my collection. I didn't want to get the original Omega ones, don't see the point. I'm not sure how long this movement did not have any case clamps. So now it should be fine with some generic ones. Here the last one coming into place. Tightening it down. Still checking the different modes. Giving a final touch up with Rodico. Removing some dust. A bit of grease in the clutch wheel. And I took the freedom to already put back the electronic module. And the watch is still running. Fantastic feeling to have saved this watch and make it run after many years probably. Still some fresh grease, silicone grease for the case back gasket. I'm not gonna go swimming with this watch, but at least it should be as waterproof as it can be. Also on top a little bit of silicone grease. And so the case back can be screwed back down. Taking the rubber ball to fasten it lightly. And there we go. Just one thing missing. And that's coming from above. The rest of the casing Here now you can see the mirror polished edge a bit better. Of course, also those 4 little screws got cleaned properly, de-rusted. And now can be screwed back into the case. The watch is also quite big for the time it got produced. 41 millimeters without a crown. So that's rather large for a vintage watch. Here you see the polish. But obviously there will be a before and after in the end. And this screw here is connecting the bracelet to the clasp. I'm covering those screw bars that connect the bracelet to the case with a bit of silicone grease. And then carefully inserting it before then also very carefully screwing it back in, which went so much easier now that all the rust was removed. Really wonderful to see it slowly come together. Also the other side, connecting the bracelet back up. Screwing it tight. And there we go. A first look at the final product. Still one thing to do. The clasp. Reconnecting. And finishing up the bracelet. Also getting pushed in with some fresh spring bars. And even though it was a lot of work, this watch could in the end be saved. The screw down crown can finally be screwed down. And even though this is not really a mechanical watch, it was one of my most fun projects yet. I gained a ton of knowledge during the process, and I hope I can give some of that on to you. I definitely got a lot more comfortable with the tuning fork movements and their complications. And I think this watch can go finally back on the wrist. Thank you so much for watching. See you in the next one.